Rational versus irrational numbers. So, rational numbers can be written as fractions and decimals. Specifically, the decimals need to either be terminating or repeating. Also, rational numbers include perfect squares and percents. Irrational numbers cannot be written as a fraction. Those types of decimals will be only non-terminating and non-repeating. Also includes non-perfect square roots, and pi is the most famous irrational number. So let's go into a little bit more about what those terms mean to make sure you understand some examples. All right, so the first one is 1.4. So this is called a rational number, and this is considered to be rational because this is a terminating decimal. And if you think of the word terminating, that usually means end. So 4 is the end of the decimal. There's nothing after the 4 other than zeros. So we call this a terminating decimal. Okay. The next number is the square root of 24. Well, if I put in Desmos the square root of 24, I will get a decimal. And that indicates that it is a non-perfect square root. And non-perfect square roots are irrational because the square root of 24 is approximately, if you put it in Desmos, it should come up around 4.8 or 4.9. So that is a whole bunch of decimals will be after that. So that's how I know it's not a perfect square. So that's called a non-perfect square. And again, a non-perfect square is any time you get a non-whole number when you take the square root of that value. The next one is 73%. If you recall, 73%, to turn that into a decimal, we would do 73 divided by 100 in Desmos, and that will give you 0.73. Okay, and if you recall, like we did earlier, that 3, the only numbers after 3 are zeros. So that means this is a rational number because it is a terminating decimal. Okay, let's go ahead and do the next one. So we have 0.141144111444 ... These ... dots indicate that that value continues on forever. So because it doesn't stop, we know that it's not considered terminating. So we say it's non-terminating because it continues forever. And not only is it non-terminating, it also has to be non-repeating. So you may think this is repeating because of the values. You only see the numbers 1 and 4. However, repeating means that the same values continue over and over. So 141414, that would be considered an example of something that is repeating. You also might see an indication that it's repeating because you might have a bar on top indicating that's a repeating decimal. This example, though, is not repeating because this is simply just a pattern. So patterns aren't considered repeating. So it's non-terminating and it is also non-repeating. When you have both conditions happening, that is called an irrational number. So again, both conditions have to happen, both non-repeating and non-terminating. Both have to happen. All right, so the next one is the square root of 225. And if you put that into Desmos, you will get a whole number, which is 15. And that 15, because it is a whole number, that tells me it is a perfect square. Because it's a whole number, not a decimal. And because it's a perfect square, that is considered a rational number. The next one we have is 1/3. So if we put that into Desmos, we would get 0.333 and so on, and this 3 repeats. So if you recall earlier, repeating decimals, so this is repeating, because it's a repeating that is called rational. So those are all some examples of what we just talked about. So let's see if we can go back to what we talked about earlier. So rational numbers, remember, that means they have to be terminating. That means ends, like 1.4. It has to be repeating, like 1/3, which is indicated with a number that continues the same value over and over. Perfect squares, that would be something like the square root of 25 because it equals a whole number. Percents, which are also out of 100, could be written as a fraction, and then it will be a terminating decimal. Then these irrational numbers cannot be written as a fraction, so they're non-terminating and non-repeating. So you can have a pattern or not a pattern. It doesn't matter. Either way, that would be a dot, dot, dot in case it goes forever, and it cannot have the same values over and over and over. And then pi, which you will see as a symbol, will also be considered non-terminating, non-repeating as well. So there's some examples that we went over. So if you'd like to go ahead and try these ones and indicate whether or not you think these are rational or irrational and provide your explanation. Go ahead and pause and try each one on your own. So once you've done that, you should have, and I'll talk about each one to make sure you understand, negative 12 is technically a decimal, which is 0.0 afterwards. So I know it is a terminating decimal. You can also write it as a fraction, negative 12 over 1. The next one is pi. Remember, pi does not end, it does not repeat, so it is considered irrational. It is non-terminating and non-repeating. 0.6, that ends. There's no value after the 6. That's rational. It is called, again, a terminating decimal. 7/8 is a fraction. It also terminates if you divide 7 by 8, and that is rational. You can say it is a terminating decimal, or it can be written as a fraction. 0.12345 dot dot dot. This dot 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 indicates it goes on forever, and there is nothing that's repeating over and over. That means it's irrational because it is non-terminating and non-repeating. 0.3 with a bar above it, that bar indicates that repeats the same value over and over. Therefore, it is rational because it repeats the same value over and over. Then we have the square root of 20, which is going to give you a decimal. And since it's a decimal, probably about 4.5, something around that. That's irrational because it's not a whole number. We call that non-perfect squares. The next one we have is negative 1.75. So the 5, there's no value afterwards, which means it's terminating. It ends. That's rational, terminating decimal. The next one is negative square root of 121, which comes out to negative 11, which is a whole number. So we call that rational and a perfect square. So hopefully those are some examples that will help you out.